Hey, what's up? Just kidding. I don't care. Time for some physics. Here's a chemical equation. Water plus plastic bottle plus air compression equals super upwards thrust of awesome sauce. No? Okay. Let's explain it in Newton's terms. Law number one. Objects in motion, or lack of motion, like to stay in motion or lack of. I'll get back to that later relating to the rocket, but first, I'm going to get a little off topic with explaining the law. Okay, here we go. Let's say your grandmother was over for Christmas dinner, and here you are, enjoying a plate of mom's homemade turkey, and bam! Grandma decided to take your turkey leg. And you're like, what's your problem, bro? And she's like, you sucker! And then you falcon punch your grandma in the face.
Falcon punch! Oh.
Now, most likely, grandma's gonna go flying until she hits a wall, and if you punch her in space, she'd be drifting away, shaking her fist at you, until she encounters something like a planet. That's Newton's first law. Kind of. I don't think he explained it that way, but whatever. Law number two. The force of an object is based on the mass times the acceleration. For example, say instead of punching grandma, you try to throw her into orbit. Well, that's just not going to happen. Why? Grandma has mass, and the Earth has gravity, which is an acceleration of 9.81 meters per second squared. Finally, law number three, for every action, there's an equal and opposite reaction. So not only does grandma put force on the wall after you punch her, the wall also puts force on her to stop her. If the force of grandma were greater than the force of the wall, she'd most likely go through the wall like the Kool-Aid Man.
I'll tell you what dream used to scare me when I was a little kid. Used to actually totally give me nightmares. Remember those Kool-Aid commercials? Where that big talking bowl of punch, he would come crashing through your wall in your living room. You wouldn't even know. He'd just, oh yeah, oh yeah, oh yeah. Right? And the little kids were all excited. Yes, yes. And then they would drink out of him after debris fell in his open, dumb head. He would pour himself. Oh yeah, oh yeah. Him and his crazy tights. I don't like that. I don't like where Juice wears tights. It's a horrible combination, a bowl of Juice wearing tights. Drinking out of him. If that was me, I'd be like, no, you fix that wall before my dad gets home from work. He's gonna beat me with a belt. He's not gonna believe a talking bowl of fruit punch came in here. You stupid idiot. Yeah, coming through the wall is real cool. Using the front door is cool. Don't touch me, you drink.
Now, bottle rocket time. Originally, I wanted my bottle rocket to be based off the reaction of cesium with water. Then I realized that it would be less of a vertical thrust and more of an horizontal explosion. So I took a liter bottle because I thought it'd be smaller and it'd give it more aerodynamics, and I made it look like Superman, but it didn't go very high. That doesn't matter because it's cute, and physics doesn't apply to cute things. Okay, maybe it does. To calculate the displacement vertically, I had to make a Klingon meter, which is this thing, which uses an angle it creates to measure vertical displacement, which is much better than trying to buy a kilometer measuring stick. Mine went about 8-ish meters, depending on how much water was in the rocket. Compared to other people's rockets, it didn't go very high, but I plan on writing a children's story called The Little Rocket That Could. So anyways, back to Newton. The rocket works by air being forced through up a valve, through water, rising to the top of the bottle and compressing. Eventually, at about 25-ish psi, the air in the bottle is like, there's too much of us in here, get out of the bottle! And it has to force itself through the water, taking the water with it. Now with every action, there's an equal and opposite reaction. As the air pushes down, the bottle pushes up and stays at that upwards motion until gravity's like, I love you, come back! And gives the bottle a nice gravitational hug back to Earth. Thankfully, the mass of the bottle isn't heavy. It doesn't create a force in the Earth deep enough to go through it and hit Satan in the face. So in a nutshell, this is how I understand physics.